Thanks for the introduction. Welcome to the jungle. I'm Rosemary Wang, and today I'm going to be talking about keeping secrets in your infrastructure pipeline. So before I even talk about keeping secrets, because keeping secrets really isn't all that fun, infrastructure pipelines are continuous integration pipelines for infrastructure as code. The idea is that when you run infrastructure as code, no matter what the tool you're using, you need a way to facilitate a deployment to production for any kind of infrastructure, whether that be cloud, data center, or even metrics. When you're using infrastructure as code, you tend to have a couple different steps in this kind of pipeline or workflow. The first is that you tend to unit test the configurations you have, make sure the configurations are what you expect them to be. You might security test them to make sure your configurations don't have something misconfigured. This could be an open security group rule. It could be a different network policy. Then you'll build and deploy this to some kind of production environment, and then you'll integration test that to make sure it functionally works. Today, we're talking about infrastructure as code using HashiCorp Terraform. HashiCorp Terraform is an open source project that you can use to deploy infrastructure to pretty much any provider that's supported, including but not limited to pizza. You can actually provision pizza using Terraform. Someone did write a plugin for that. So check out Terraform as an open source project. I've done a lot of these infrastructure pipelines before, and they usually follow this general approach, which is plan, security test, apply, and then check if everything is working. But there's kind of a problem when I use these pipelines. For example, sometimes I'll go back to pipelines and realize that some of the secrets I was using were actually about a year old, and I never touched them. The pipeline had continued running on its merry way, but I had never changed that set of secrets or that sensitive information. This is actually a view of my pipeline that I had not run for about a year, and it had some Azure credentials that were about a year old. So basically, I was deploying to Azure, and I could continue to deploy to Azure with the same username, effectively username, passwords, and tokens that I had done for about a year. The other problem is that sometimes my security tests fail, or I'll review some pull requests and realize in horror that I committed the database password. In a previous session, you probably learned a little bit about how you can scan for secrets in your GitHub pipeline, GitHub Actions workflow. However, in this particular situation, I didn't catch it before I went to production. Instead, I sort of caught it when I had already done it. And actually recently, I printed out my database password in a pull request by accident. So either way, none of these scenarios are great. Either you have long-lived secrets or you accidentally printed out your password in plain text. So after this situation happens, I usually invoke Plan R. Plan R has a couple of steps to it. The first step is regret everything. Regret that you became an engineer, regret that you started to do DevOps and all of these things, regret that you started to learn infrastructure as code and dared to touch cloud infrastructure. So after you get over that step, the next step that you think about is revoking the password or the token that you were using. In the case of my long-lived credentials, I would revoke it, and then I would rotate it with a new one. So this happens with a number of sensitive sort of variables that you might have in your pipelines. The next thing you do is find all references. This could mean that your database password was referenced by multiple applications. It could mean that it was referenced by one or two other repositories. You don't know where it was referenced, but you have to find them. And the next is to replace. So basically steps 4 and 5 tend to relate to a Control F and Control R. That is our automation for referencing and replacing any instance of that sensitive variable that we've compromised. And then we rerun everything. The one time that I committed a database password and had to rotate it, I think it took 10 or 15 pipelines retriggering and running and basically redeploying. So Plan R is an extensive plan. Sometimes it can take 2 days, other times it can take 7 weeks. You never know what it will take. All right, so when I became a developer advocate, I started to think, is there a better way to do this? It turns out there is a better way to do this, and it's with another open source tool called HashiCorp Vault. HashiCorp Vault is going to handle a couple of different types of secrets. HashiCorp Vault will actually store and rotate service accounts. So these are things that log into an infrastructure provider They'll store any kind of sensitive resource attribute that you need, including database passwords or certificates. And you can also have it generate some secrets for you. Actually, this subset of things is kind of the stuff that you would put in your pipeline. If you think about the secrets in your pipeline, they usually fall into one of these three buckets. So things that you need to log into an infrastructure provider, these are API tokens or service account keys. You also have resource attributes. These are database passwords or certificates. So you might pass an admin password to a resource to make sure you start up a database with the right login. And then you also have generated secrets. So these are things that the pipeline itself creates. These could be random passwords or tokens. We're only going to talk about the first two, which is service accounts and resource attributes, because generating secrets tends to be an output. Securing output is a whole other talk. And so what we're going to do is focus on the first part of this talk, which is keeping your secrets indeed a secret as inputs. So when you use a secrets manager, what do you do and why do you bother using it? Well, a secrets manager actually takes away a couple of steps. The first thing is regret. You might push a password and regret that you pushed it in the first place, but you actually get the simplification of the revocation and the rotation of secrets with the secrets manager. So if you need to change the secret, it's no big deal. The next is actually the reference step. You still have to find pipelines that are referencing it. You still have to find applications that are referencing it. But at the end of the day, the bulk of the revocation and the rotation are handled by a secrets manager. And then you follow the rerun command. So sometimes you have to rerun it, other times you don't. Depends on what your automation supports. At the end of the day, you kind of remove the regret and the replace step for the most part. Vault, as a secrets manager, will handle that for you. And for the most part, you can go and use the new database password or service account without any other thoughts. All right, so the way that secrets get into a pipeline in the first place, specifically an infrastructure pipeline, is this process of secrets injection. The first step is to authenticate to said secrets manager. You can't just get a secret. You need to authenticate to your secrets manager first. And then the second step is to actually introduce the secret or get the secret from it. After that, you can pass it to your pipeline for usage. In the case of Vault, what we can do is consolidate these two steps. So we would first authenticate to Vault, and then we would get the secrets at a specific API path in the secrets manager, and we pass this through. The consolidation of these two steps actually is done by the Vault GitHub action. It's an open source GitHub action. You can use it in any of our pipelines. We also have a Terraform GitHub action. So you get to automate this end-to-end process and take away the pain of this workflow using GitHub Actions specifically. So today, we're actually going to look at this in action. It's going to get a little complicated, but I'm going to try to articulate some of the design elements in this particular demo. The first thing is that I have an infrastructure pipeline using GitHub Actions. So it's a repository that has some Terraform configuration in it, and I expect to deploy it to Amazon Web Services today. What I'll do is I'll tell this infrastructure pipeline to authenticate to Vault first. After it's authenticated to Vault, the GitHub action for Vault will retrieve the secrets that I want. So I'll tell it to retrieve a static secret with an admin token. The reason why I want a static secret for my database and not just a dynamic credential to start is that, well, my database doesn't actually exist yet. So I can't really create a database password and username without the database existing first. So I have to be deliberate about passing the admin password there. So I'll retrieve it, and then I'll retrieve the AWS credentials. So this two-step process will allow me to authenticate to Vault and ultimately get the secrets I need for my pipeline to run. The next step is to basically tell AWS, hey, I want to log in. And AWS will tell me, okay, here's a token. After I get that token, I can create that managed database. And after I've created that managed database, I can continue to configure Vault to basically get a set of read-only credentials for the application. Something important to understand about this workflow is that some of these things are over public internet. You can put everything over a private connection if you actually create self-hosted runners, or you put them in the same virtual peering connection, or you peer together with a virtual peering VPC with the peering connection between them. In the case of the Vault instance, The Vault instance actually is privately connecting to the database. So the database itself doesn't have any public connection, but the Vault instance that I'm using is a managed Vault instance, and it is publicly available. So the GitHub action is actually connecting to my secrets manager over public. Again, you can configure this all private from a security standpoint, but for today's demo, I'll just demonstrate it over the public internet. All right, so this is the workflow at a very high level. Let's dig deeper into the code itself. I'm going to try to share my screen and hope that it is large enough for everyone. All right. Sure. All right. So unfortunately, you will not have my view, my face on your view, unfortunately. But what I have is actually the code base. If you would like to see more of this code base, you can take a look on GitHub. It's at my handle there. So the first thing we're going to actually take a look at is the workflow itself. This is actually really amazing to me because it's so simplistic. The first thing that I did was add the Vault GitHub action. The Vault GitHub action has a set of parameters that take in the URL of the Vault instance. For me, I use it as a GitHub secret, so the Vault address, role, and secret, as well as the namespace. And it will actually go and authenticate to Vault without me needing to do anything else. The next important thing that it will do is retrieve secrets from my Vault database, or my Vault secrets engines. So Vault has a set of plugins that will rotate all of these kinds of secrets for you. You can enable them selectively. So I, for example, have enabled a static key value store. This stores my static database login and database password. I also enabled the AWS secrets engine. The AWS secrets engine will actually handle the rotation of AWS tokens and access keys and secret access keys, depending on how you configure it. I also have a token just to store my Terraform state. If you're familiar with Terraform, Terraform creates infrastructure and it needs to store the state of that infrastructure somewhere. So this is for me to securely store that state. If I actually examine this rough API path in Vault, the API path in Vault sort of looks like this. You have an AWS API path here, which is the infrastructure pipeline / AWS. I also have the AWS, the static section for specifically database passwords and usernames. All of this is available. All right, so what I've done is actually pre-stage the database. The reason why I pre-stage the database is that sometimes databases take a little bit of time to provision. The database is up and running already in AWS. What I'm going to do is actually configure the second part of this with a pull request. Using the Terraform GitHub action, I can plan the Terraform that I expect to use. So for example, this Terraform is going to configure Vault for me. It will actually add a new secret backend for my Postgres database that I've provisioned in AWS. When I actually run the plan, it will funnel this back to my pull request. So you can see all of the plan information. You can verify from a team standpoint. Sometimes you want to check if these connections are correct or if you maybe misconfigured something. Another neat, important feature that happened in Terraform 0.14, open source, recently released, is actually the mark of sensitive variables. So it will actually redact certain sensitive variables if you mark them in your Terraform configuration in the first place. So all of this is actually planning to put a new database secret engine, and basically this will handle the rotation of database passwords. So while this actually runs, I'm going to confirm and merge the request. All right. While that runs, I'll actually show the AWS portion. So remember I said that the pipeline has to connect to AWS. The important way that it connects to AWS is through the revocation and rotation of an STS token. This token for AWS only lives for about 30 minutes. And this is important to understand because I'm keeping it a secret through ephemerality. I'm not letting it stick around. So remember in my previous example, I put in 1 year for a secret and I never touched it. In this case, my secret only lasts for 30 minutes. I've run this pipeline about 4 times in the past hour, and the 3 times that I had run it already expired. So that's actually what you see when I list the leases, which is the passwords that have been generated for AWS. I just ran this, so I got one AWS credential on demand. The next time I run this, I'll get another AWS credential on demand. I tune the kind of configuration I want for the time to live of that secret. If I don't need that AWS credential for more than an hour, I don't need it for more than an hour. My recommendation is tune the credentials that you need for the amount of time based on how long your pipeline runs, right? In the case of infrastructure pipelines, some of them can be very long running. They can be like an hour because you're creating those resources. So make sure you give it enough time so that the pipeline can use the set of credentials properly. But in this case, I have a set of one credential because I've only run this pipeline once. You also notice that I've printed the Vault credential, Vault generation of database credentials, and it says there's no value. Basically, I haven't generated any database credentials yet. I'm using a static database password for the admin. I can always change that. All right, so let's see if this is done running. Hopefully it's done running. It's still running. All right, so this is done. In this GitHub Actions workflow, I've set up a couple steps. Again, importing the secrets, I verified to make sure that they've been injected into the pipeline. Remember, this is the AWS secret and the static database password. I'll also set up Terraform as well as format and initialize and apply everything. So now this is actually a database that I can run and try to log into. All right, so finally, the second portion of this, and I think the most interesting portion. Remember, the database password can be used by a lot of different applications. It can be used by many different people for even just verification, debugging, and tracking. What I can do is now create a database credential on demand. So if I am going to go and, let's say, log into this database read-only, I just want to have my application pull some information from it, I can actually request to Vault and say, hey, can you just give me a database credential? So that's actually what I'm going to do. I'm going to get a database credential. And hopefully I'm typing the right command because I didn't feel like copying and pasting today. All right. Let's do this. By the way, if you actually want to refer to more of this, you're welcome to go into this repository and try to run it on your own. It does configure Vault for you. And I did not get into exactly some of the Vault configurations. If you're actually doing this in your organization, you want a Vault administrator who has configured this for you, a good portion of this for you. So in this case, I have retrieved a read-only database credential. This is read-only by configuration. My Vault administrator, which is me, configured this to be read-only. And now we've got a Vault list. So when I list the credentials that I've generated, I only have one set of database credentials, which is really powerful. If I issue and try to get another set of database credentials, I'll actually see two database credentials issued. I did not print out the password, by the way. I was told do not print out passwords during live demos. This is a username, so don't fear. This is a username. It will get revoked in about 20 minutes. I've set the time to live for the database credential specifically to 20 minutes. And the database itself is not publicly accessible. So unless you can find the database and access it, there's not much you can do. But basically, the whole workflow that I've demonstrated here allows you to retrieve secrets on demand. No matter what kind of application you have, no matter what kind of information you're trying to store, the idea is that you can go to a secrets manager. The secrets manager will handle all of the steps you need in order to keep a secret, especially in a pipeline. There are a lot of deeper nuances to configuring some of this workflow, especially if you've got different methods and different databases. For example, in the high-level architecture that I have here, I'm using some specific authentication methods. You can use authentication methods to Vault for GitHub, for example. And you will have to configure that as part of your GitHub action, but all of it is open source and all of it is supported. So you're welcome to go dig into the documentation. And if you have any questions, you're more than welcome to reach out to me or any of the team at HashiCorp. Finally, next, please. All right. Finally, if you want to reference this pipeline, I'm putting the URL here for additional reference. And if you are curious, you want to take it and reverse engineer it and try to do it yourself. And the other thing is, if you have little knowledge on Vault or you're trying to get more familiar with Terraform and Vault, I'll have a list of references here as well as the session resources. Take a look at some of the links. We have tutorials. We also have guides on how you would configure this for your own workflow needs. Thank you, and I hope you learned how to keep your secrets and your infrastructure pipeline a secret.